We're going to take a look at area of trapezoids, and so to show you guys where the area of a trapezoid comes from, if we draw a trapezoid, the definition of a trapezoid is that the top and the bottom bases are parallel to each other. For every trapezoid that you draw, you can divide it into two triangles. And one of the triangles, the base happens to be the bottom of, or basically one of the parallel lines. So let's call that base 2. And then the base above that, the other base is parallel to base 2, which we'll call base 1. So if we were asked to find the area of the trapezoid, I might first find the area of this triangle and then find the area of the other unshaded triangle, both of which have the same altitude of h. So the area of a triangle, let's say the shaded triangle, the area of shaded triangle is equal to 1/2 base times height. So B1 times the height. Whereas the area of the unshaded triangle above there, or to the left there, is 1/2. And the base of this triangle is B2. The height also happens to be the same height as the first triangle. So 1/2 B2 times h. Now, to find the area of the trapezoid, I would add these two together. So our area of the first shaded triangle plus the area of the second unshaded triangle. Notice that the two terms have 1/2 in it as well as an h in it. So if I factor out the 1/2 and the h, I get B1 plus B2 inside the parentheses. And that is the same formula you see shaded right there. Oftentimes you either see the area of the trapezoid written like that, or sometimes the h is moved above the 2, and you see the formula written like you have down below. As well as a third way of writing it is the area of a trapezoid also happens to be equal to the average of the bases times the height. And that's also another way to describe it. So I'll box this part and say the average of bases. And average is just the sum divided by 2 if there's two quantities. Average of bases. So let's take a look at some questions down below here. JKLM is a trapezoid with a median of NO. And a median simply cuts across the trapezoid at the midpoint of the legs. Okay, so in this case, the median is this segment right here. And the median will also define above, I know we had mentioned the average of the bases. Another way of saying average of bases is also the median. So sometimes we would say that the median, the length of the median is the average of the bases, and we've defined that before. And so sometimes the area of a trapezoid simply is described as the median times the height. So down below here, as we go through these problems, I'll mark off the trapezoid as we go so we can have a nice clean one as I erase to go to the next problem. So if LK is equal to 16, so above here, LK is equal to 16. You've got JM is equal to 24. Now highlight that as well. And KJ is equal to 6. Let's use a different color here. KJ is equal to 6, so that looks like our height. So for the first case, they give us all the information we need to solve for the area of a trapezoid pretty easily. So the area of this trapezoid is equal to 1/2. The height is 6. Height is altitude. And then the sum of the bases. So 16 plus 24. So we have, when we simplify this, we do half of 6 first, which is 3. And then 16 plus 24 is 40. So we see that the area of the trapezoid is 120. And our units of measure is square units because we're doing area. Now on the next problem, let's go ahead and relabel our trapezoid. We have JP is equal to 10. So this is only a portion of the bottom base. LM is equal to 5. And LM, by the way, is not the height, right? That's kind of a slanted leg right there, not the altitude. So LM is 5, and then PM is 4. Find the area of JKLM, which is the trapezoid. So given that we know part of the information that we need, which is the bottom base, we're missing the top base, but we see that the altitude cuts across the bottom base such that it divides the bottom base into 2 segments, 10 and 4. So if we think about it, the top portion of this must be equal to the bottom portion here. So therefore, we can make a conclusion that KL is equal to 10. Now, if we're trying to determine what we need to find the area, we also happen to need the height of the trapezoid, which we can determine by the fact that you have a triangle here. And that triangle is a 3, 4, 5 triangle. So this is not drawn to scale because that would mean that this height is equal to 3. Now, putting all that information together, the area of the trapezoid is going to be equal to 1/2 times the height, which is 3, times the sum of the bases, and the bases are 10, plus the bottom base must be the sum of 10 and 4, so 14. So we got 1/2 times 3 times 24. If it's easier for me to take a half of 24, I'm going to go ahead and do that, and that's going to give me 2 goes into 24 12 times. 12 times 3 is 36. And the units of measure in this case for this particular trapezoid is centimeters squared. Now for number 3, let's go ahead and see what we have for 3. So for 3, we have that we're given, and let me make sure I erase everything here. So for 3, you're given that Kn is equal to 3. You've got Jm is equal to 23 inches, so the entire bottom base. KL is 17. Find the area of JKLM. So if Kn is 3, we can also make the conclusion that, and I'll switch colors so we can see what we're not given. We can also make a conclusion that NJ is also 3, since the median cuts across the middle. We'll know that this is congruent to this. And so the height, therefore, we can conclude is equal to 6. So the height is 6, 3 plus 3. And so what else are we missing? I think that's it. We have all the information we need. So the area of this trapezoid is going to be equal to half of the height, which is 6, plus the sum of your bases, which is 17 and 23. So half of 6 is 3, and then we've got 17 plus 23 is 40. So this also happens to be 120 and inches squared as well. And our very last example, let's see what we have here. If Jm is equal to 25, so Jm is equal to 25, so the entire bottom base is 25, and you've got KL is equal to 17. Find the area of and the area of JKLM is 147. So this time they give me the area of the trapezoid, and I'm asked to determine what LP is. If I go back to the diagram, we're going to call LPX, and if I look at the diagram, that's going to be my height. So the area of the trapezoid, I'm going to substitute out that with 147. The height is what I'm trying to solve for, which I can go ahead and call that x, so x over 2. And the basis they give me information on, so 25 plus 17. So if I add 25 and 17, I get 42. So 147 equals x over 2 times 42. 2 happens to go into 42 nicely, exactly 21 times. So we've got 21x is equal to 147. So 21x equals 147. So if I solve for that, I get x equals 7 centimeters. Centimeters because that's a measurement of height.